Okay, so this is part B and C to the question 7 exercise 3G hypothesis testing. Check out my part A if you want to know more about the standard, normal, and how to work those things out. Okay, so part B. So we're told that 8 water voles are chosen at random. So let me just tell you, from part A we worked out the mean of these water voles to be 136.48. If that helps, I'm not sure it will, but just in case it's here. Fine. So 8 water voles are chosen at random. Find the probability that we have at least 4 that's a mass greater than that. Okay, so straight away this question is screaming out, Ethan, I'm a binomial distribution question. Why is it a binomial distribution question? Well, there's a fixed number of trials. The trials are independent of each other. One water vole having a certain mass isn't going to affect the next one. There's a probability of success and probability of failure, and that is constant. Now, the probability of success and failure is going to be calculated using the normal distribution, M. So we worked out M has a normal distribution with parameters mu, which is 136.48, and with standard deviation, it says 12, so the variance is 12 squared. We're going to work out M is bigger than 150. Of course, this is a continuous distribution, so it makes absolutely no difference if I use this strict inequality or using the equality with a strict inequality. It doesn't make a difference because it's a continuous distribution. And just on a side note, if you want to understand that, if we have a normal distribution curve and we want to work out the probability, so this is 100 and what is over here, 136.48. Say we want to work out the probability that is equal to 160. What would that be? Well, it's obviously going to be 0. Why is it going to be 0? Well, the way I like to explain it, I think it's quite intuitive. The area under the graph is the probability. So if you work out the area of a straight line, what's the area of a straight line? I think it's 0. Why is it 0? Because there's no change in the base. There's no change in x. So the area of a straight line is 0. So the area of a straight line is 0. Okay, I'm going to rub that out, but that's why there's no difference between writing this and this. They are exactly the same things. Okay, fantastic. So going back to the question, I'm going to say, I'm literally just going to use my calculator, my Casio FX991EX, that's the best one to have. Here we're going to go to menu setup, 7 is distribution, we're going to click normal CD for cumulative distribution. The lower is going to be 150, the upper is going to be a huge number, let's say 1000. Why? Because we want to make sure that the range under the graph is big enough. Because there's an asymptote, basically this line here is an asymptote, we need a very, very large number. Sigma is going to be 12 and the mean is going to be 136.48. And putting that into my calculator, it gives me 0.1299. Fantastic. So now we can use a binomial distribution to work out, so I can call it x. X is a binomial distribution. The number of trials is 8, and the probability of success, so the probability of having a mass greater than 150, is 0.1299. We're working out the probability that we have to have at least 4. So bigger than or equal to 4. Because at least 4 means, well, you have to be 4 and you have to be bigger than 4. And it's really important that we do include this equality under this inequality sign, because a binomial distribution is a discrete distribution. That means the values, in this case we have 8, so the values are, they can only take whole number integer values. So what, 0, 1, 2, 3, 4, 5, 6, 7, 8. The probability that we're bigger than 4, so 4 is here, probability that we're bigger than 4 is all of this up to 8. So Px is bigger than or equal to 4. So that means we're 4, 5, 6, 7, or 8. Fantastic. So how do you work that out? Well, we need to think about it. So if we go from 0 to 3, that probability, so the probability that x is less than or equal to 3, in other words, 3, 2, 1, 0. If we add these probabilities together, what are we going to get? Well, we're going to get 1. Why? Because the probability of getting a 0, a 1, a 2, a 3, a 4, a 5, 6, 7, and 8, in other words, in this context, having your water voles 0 bigger than 150, 1 being bigger than 150, 2 being bigger than 150, it's all the different possible outcomes. And in a probability distribution, it lists all the possible outcomes and they always come out to be equal to 1. Okay, so that's that. So to work out the property that we're bigger than 4, we're just going to rearrange this formula here. So the probability that we're less than 3 or equal to 3, bigger than or equal to 4 is equal to 1. Let's quickly rearrange this formula here, and we get 1 minus the probability that we're less than or equal to 3. And now you can put that in your calculator using the binomial CD function, which is on your calculator. You just put n as 8 and the probability is the same as this, 0.21299, and you're going to get 0.0129. So very, very unlikely, which makes sense. Okay, I'm going to do part C in a separate video. I hope that was useful. I hope this helped you understand the binomial distribution a bit better too. Thank you.